Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our third and final video on direct algebraic proof, and with particular focus on quadratics for this one. I'm going to launch straight into examples. You must have watched direct algebraic proof 1 and 2 beforehand. So let's go straight into an example. Prove that 2n add 3 all squared, subtract 2n subtract 3 all squared is a multiple of 8 for all positive integers of n. All we need to do really is we need to take this expression here, we need to expand it and see if we can make it look like 8 times a positive whole number. So let's give that a go. Let's write 2n add 3 all squared, subtract 2n take away 3 all squared. Now what does that mean again? That means 2n add 3 multiplied by 2n add 3 take away 2n subtract 3 multiplied by 2n subtract 3. Now remember, this subtract is subtracting the whole answer here. So you know what? Let me put a big square bracket around that to like protect it and tell us that it's everything in this first bracket, which, you know what? I'm going to put a big bracket around that as well. So let's multiply this out and see what we get. 2n times 2n, that's 4n squared. 2n times 3 is add 6n. 3 times 2n is add another 6n. 3 times 3 is 9. Square bracket, take away. The answer when you do this. Now you should be able to do this quickly. I would get 4n squared, subtract 6n, subtract 6n, add 9. Right? So let's do a bit of tidying up. In this bracket, I can collect like terms. I can collect a positive 6n and a positive 6n. And in this bracket, I can collect negative 6n and negative 6n, right? So I can say, therefore, this is equal to 4n squared, add 12n, add 9. And I can say that's subtract 4n squared, take away 12n, add 9. So let's think what this means. I can think of this, as if you will, as negative 1 multiplied by the whole of this bracket, if you would like. And I can just think of this as 1 times the whole of this bracket. So I can basically remove the brackets and write, therefore, that 4n squared, add 12n, add 9. Now I'm going to multiply everything by negative 1, subtract 4n squared, add 12n, take away 9, right? And 4n squared, take away 4n squared, is no n squareds. 9 subtract 9 is nothing. And we're left with, at the end, look, 24n. So it's in the 24 times tables. We wanted to show it's a multiple of 8. So all we've got to do is just take out a factor of 8, because I can take out a factor of 8 because I know 8 times 3 is 24. So if I took out a factor of 8, it would be 8 multiplied by 3n. And we have shown if n is a positive integer, 3n is a positive integer. So therefore, this is of the form 8 times a positive integer, therefore multiple of 8. And we're done. And there we go, using our knowledge of quadratics to expand out this quite complicated expression, but in the end show it came down to 8 times a number, a positive whole number. Right, let's give another one a go, link into a skill that we should know about quadratics. Prove that x squared add x add 1 is bigger than 0 for all x. That's a tricky one now. Well, you could have a think. I'm going to just teach you a little trick for this. When you get questions like this, completing the square is really going to help you. Because completing the square writes this expression in a nice square form. And you know things that are square numbers are positive numbers. And that might help you show it's bigger than 0. So let's complete the square here. What we would do is we would say x plus, and that number there is really a 1, so we would half that number. So it's x plus a half squared, right? Then we need to think to ourselves, if I expanded that out, I would get x squared plus 1x plus a quarter. So I need to take off that quarter, and don't forget to add back this 1 here. Please go and look at completing the square if you don't know about this. And this therefore is going to be x plus a half squared. 1 take away a quarter is positive 3/4. Now actually, would you believe it, we've shown it here. I wonder if you can see it. 3/4 is a positive number. X add a half squared, anything squared is bigger than or equal to 0. So therefore, we could say that x add a half squared, I know for sure that that could be 0, but it's bigger than or equal to 0. And therefore I know x plus a half squared add 3/4. Well, because this thing is bigger than or equal to 0, something bigger than or equal to 0 add 3/4 is definitely bigger than 3/4. It's so it's certainly bigger than 0. And therefore we have shown that this is true for all x. So when you got something like this, complete the square and you will get something that you can prove, well, this bit is bigger than or equal to 0, added on to something that's positive certainly gives you a positive answer, and we're done. Okay, let's give that one a go, and let me give you a little hint that this also is going to be completing the square. Well, to show that this is bigger than this, what we could do is follows. We could complete the square on this side. Let's give that a go. So we could say that x squared add 4x add 8, let's complete the square, is identical to x add, we half that number, 2 squared, right? X add 2 squared, we would get x squared add 4x add 4. So take away that 4 and don't forget to add back that 8 there. Now if we combine that, we get x add 2 all squared, and negative 4 plus 8 is positive 4. And we have actually done it, would you believe it, because this little thing here, x add 2 all squared, is bigger than or equal to 0 because it's a square number. So therefore x add 2 all squared plus a 4, adding 4 to both sides, must be bigger than or equal to 4. And we have done what we've been asked to by that little trick of completing the square. And that's it for Direct Algebraic Proof 3. Thank you very much for watching.